Doctor, unmute.
All right, thank you, Ivani. All right, sure. Good morning, everyone. Sorry, repeat back. Good afternoon, everyone. Okay, so just to recap back before I start the class for today, we have already started last Thursday, chapter 5, sorry, collection and analysis of our experimental data. With the aim is actually to obtain the two information, which is the rate law through the reaction order. By knowing the reaction order, you will then be able to determine the rate law as well as the value of K. So I told you last week, we have different methods. So when we have different method, we have different equation. So when you have different equation, you will need to plot different types of graph. Although I do tell you that in my assessment, you do not need to plot the graph. The graph is given to you, but it's also important to know that you may need to understand how to apply the equation, correlate with the plot to answer the questions lah. Meaning in chapter 5, ultimately kita nak cari reaction order, alpha as well as the value of reaction rate constant, value of K. So last week I already covered chapter 1, method 1, method 2, half-life and differential method, right? So we're going to go to the third method, integral, which is only the top 3 method that we will discuss thoroughly. And initial rate is just something that I will just explain to you, but you will not be further evaluated on your understanding for the fourth method, right? So this should be quite a short lecture for today. So next one is integral method, right? Okay. If you remember, I told you before this, every method ada pro and cons there. So the other two method, I already explained to you the pro and cons. Ultimately, the main pro of these two half-life and differential method, yang dua method that you learned previously, when you use this method to elucidate or to determine the reaction order and the value of K, you can go into it usually for the types of reaction di mana you do not have prior knowledge of the value of K or the rate law. Maksud saya, contohnya kalau kamu ada tindak balas yang baru, contohnya if let's say you change reactant or you predict that it may be new kinds of reaction mechanism of which you have no idea at all what will be the reaction order and the value of K, it is highly beneficial for you to choose the two method that we learned previously, half-life method dengan differential method. Okay, meaning let's say, saya tindak balas baru, saya tak ada idea langsung daripada literature, nobody has done this reaction, I got no idea. Okay, I tak tahu sama ada dia zero order ke, first order ke, second order, value K pun tak tahu langsung. Method, the two initial method is easier. Is recommended. Tetapi kalau kamu ingat, bila saya ajar dua method yang sebelum ni, dia ada cons dia juga, right? Let's say half-life method, kamu kena buat banyak eksperimen. Kalau differential method, kamu ingat kalau kamu nak plot graph tu tak senang kan? Kamu ada banyak pengiraan lah, kena guna formula ni lah, formula tu lah, baru boleh plot graph. So dia ada pro and cons dia. Okay, so same as integral method, dia ada pro and cons dia. The pro of this method is that method ni equation nak plot graph dia is much easier. Even nak dapatkan data, untuk dapatkan graph pun, information tu quite straightforward. Eksperimen dia pun senang. Okay, eksperimen dia very easy, okay, very straightforward. Sekali run eksperimen ataupun basically dalam eksperimen kamu tu, what you do is, okay, you put in initial concentration of your A, reactant A in your reactor. You just record what is the change of the concentration of A with time. Let's say every 5 minutes ke, every 10 minutes. So satu kali eksperimen, just catat data, okay, what is the changes of the concentration with time. Let's say after 1 hour, done. So kamu tak payah repeatedly buat eksperimen. So that is the pro of the experiment. The cons of the experiment is that kalau method yang sebelumnya, in half-life method and differential method, you only apply one equation. Based on satu equation, plot graph, kita dah boleh tahu alpha dan K. Integral method ni, dia punya main cons is that you have different equation for different reaction order. Maksudnya kalau zero order, I have different equation. Means saya kena plot graph mengikut equation untuk zero order. Katakan dia first order, I have another equation of which saya kena plot graph berdasarkan based on equation untuk first order. Okay, so benda yang kamu nak plot tu takkan sama kalau dia adalah zero order, first order, and imagine kalau ada second order, so on and so forth. So in my class, I only cover the common reaction order, zero order, first order, second order. So imagine dia ada 3 equation yang kamu kena plot graph, di mana the data that you will need to plot the graph will be different. Okay, so that's the question come. Kalau kamu ada tindak balas yang baru, mana kita tahu dia reaction order mana satu? Dia reaction order 0 ke, 1 ke, 2? Kita takkan tahu kalau dia adalah reaction yang baru. So you have to do somewhat trial and error. Maksud saya adalah, kamu kena faham the reaction mechanism or the rate law, dia dah memang spesifik. Kalau dia zero order lah. Kalau dia first order lah. Kalau dia second order lah. So kalau dia adalah tindak balas zero order dan kamu plot graph according to the equation for zero order, hanya tindak balas yang zero order akan fulfill the requirement of the plot. So katakan kalau dia tindak balas first order, kamu plot zero order punya equation, you will not get the desire or the expected plot yang you nak. So erti kata lain, when I have a zero order reaction, only zero order reaction, when I plot their data, I will get the exact graph that I want. Maknanya nanti saya akan ajar kamu, kalau zero order, kita plot apa dia punya requirement, baru kita boleh confirm dia adalah zero order. So same as first order. Let's say kalau equation tu bukan, kalau reaction tu bukan first order, I plot experimental data dia menggunakan first order punya equation, plot yang kamu akan dapat tu takkan memenuhi the requirement for us to say this is conclusively first order reaction. The same as the rest. So erti kata lain, if you, let's say in terms of clothes size, so if let's say you are M size, okay, you will only fit to M size, you can never go to S size. Something like that. It's very custom made to the reaction. So hanya reaction tu akan memenuhi the rate law yang sepatutnya. So the cons is, kalau saya tak tahu, saya kena try and error. Means saya katakan saya ada tindak balas baru ni, saya tak sure dia zero order ke, first order ke, second order. Means saya buat eksperimen ni, saya plot zero order. Tengok plot saya tu fulfill tak requirement dia. Kalau fulfill, okay, I can conclude it's zero order. Let's say it does not fulfill the requirement. Okay, saya try error pula. First order punya equation, saya plot satu lagi graph. Saya tengok balik, saya tengok fit tak, betul tak memenuhi the requirement for us to say is first order. Kalau tak, try pula second order, so on and so forth. So that's why the cons is, if you do not have prior information about the rate law, particularly the reaction order, integral method is not recommended because you have to do trial and error for many of the reaction order. Okay, so you may ask, then kenapa kita belajar integral method? So integral method is usually to verify. Katakan kamu menggunakan a common reaction which a lot of people has reported on the rate law. Tapi kamu nak verify ataupun kamu nak just confirm, betul tak katakan the journal says reaction ni mesti first order reaction with respect to A. So you collect the experimental data, you just plot the first order. Okay, so kalau they fulfill the requirement for the first order plot, so you can further confirm, yes, this reaction, literature tu betul, memang reaction ini akan memenuhi first order reaction. So you must understand, dia order of reaction tu bergantung kepada tindak balas. Orang A, orang B, orang C, dia run eksperimen, kalau dia menggunakan the same raw material, the same type of reaction, the rate law will be the same for anybody who conducted the same experiment for the same reaction. So that's the pro of integral methods. Kalau saya dah ada information, saya just nak verify, saya boleh guna this method. So same lah, bila kamu dah dapat plot graph, okay, two things. First, you can verify the reaction order, and from the plot, then later on I will teach you how we get the value of K. So the value of K yang kamu dapat pun kamu boleh confirm, you can compare as well with the literature. Betul tak nilai K yang saya dapat? Sama tak dengan nilai K yang dapat daripada literature? So you must understand, if you're running the same reaction, of which all the conditions are the same, you should get the same K value. Value K tak bergantung kepada siapa yang buat eksperimen tu, tak bergantung kepada batch reactor mana. You use the same type of batch reactor, as long as you use batch reactor, the value of K should be the same as well. Right? Okay, so that's what we're going to do. Right, so But before we plot the graph, we have to first understand the equation. So how do we do it? So if you remember, this yellow box equation seems familiar because it was the same equation yang I teach you last week for differential method. Just that kalau differential method, we will differentiate the equation. Kalau dia integral method, I think you can guess, kita akan integrate pula. So kenapa? Sebab tu kita boleh dapat equation yang berlainan. Okay, Zulfaqar akan ada soalan ke ataupun terbuka mic? Okay, alright. Okay, so that's different. Method ni apabila equation yang sama, because this equation explains about the loss of the orders change of the concentration of A with time. Kan saya ajar kamu pembezaan dCA per dt ni maksudnya adalah perubahan kepekatan A terhadap masa. Because you know reaction A will be consumed. So then why we have a negative sign? Sebab kita tahu kalau A adalah reactant, in a reaction, the reactant A will decrease because they will be consumed. That's why the negative must be there because kita tahu quantitatively kepekatan A mesti berkurangan dengan tidak balas. Kalau dia tidak balas, tidak berbalik, irreversible kan? Because I taught you before reversible, so kamu pun dapat konsep hanya tidak balas yang tidak berbalik dan baru kepekatan A akan menurun dengan masa. So this is equal to or same with our rate law, which is the same as KCA power alpha. Okay, so sekarang tu yang jadi masalah dia sebab bila kita nak integrate equation tu, kita dah kena sekarang assume bila A adalah zero order. Bila alpha is zero order, bila alpha is first order, bila alpha second order. That's why you got different equation. Okay, so we go to the very first equation. Let's say sekarang we assume dia adalah zero order reaction. Means kita dah sekarang assume kita nak integrate the equation if this is a zero order equation. Okay, so I will not explain in detail the derivation. What's more important is understanding the final equation. In fact, the final equation is also given to you, so you don't have to worry. But you have to understand lah, kalau zero order equation apa, first order equation apa, second order equation apa. Okay, so let's say after the equation for zero order, means alpha is zero, we will get the integral equation as CA equals to minus KT plus CA non. Okay, again, macam mana kita dapat derive ni adalah apabila minus RA equals to K, CA power 0. So you know kalau something that power kosong dia dah menjadi 1. 1 multiplied by K is K, right? So when they integrate this equation, that's why you get your final equation. So you must remember, again, kena correlate dengan apa experimental data kita. Ingat, tadi saya kata dalam eksperimen kita, data yang kita akan ada adalah masa dan kita punya kepekatan A, CA. We have CA, we have time. So from this equation, again, kita nak buat plot graph di mana we will have a straight linear line ataupun straight line. So kalau nak dapat equation, nak dapat plot yang dengan straight line, kenalah equation dia berdasarkan y equals to mx plus c. So you can see that my CA concentration, my concentration of A will become my y-axis punya data. So maknanya data pasti Y saya adalah data CA saya. Then naturally my T, the time, will be the data for my x-axis. So ingat, kalau kita nak plot graph, mesti berdasarkan data yang kita ada kan. Data eksperimen kita adalah CA dan time. So kita fit data yang kita ada dengan equation yang kita dah develop. So kita tengok, CA will be my y-axis, T will be my x-axis. Okay, so of course, naturally, your M, your gradient of the plot will be your minus K, and your CA naught will be your y-intercept. Okay, so first of all, okay, kamu kan, remember I told you, kamu kena verify dulu, betul tak data kamu tu adalah zero order reaction. So what you going to do? You have your experimental data. So for zero order reaction, kamu kena plot graph CA melawan time. Okay, then if and only if kalau reaction kamu zero order, hanya dan jika hanya if your reaction is zero order, your plot akan fulfill dua requirement. They must fulfill both requirement, then only you can verify yang tidak balas kamu tu zero order. Okay, that two requirement is that, first of all, plot yang kamu plot tu mesti negative slope. Okay, so katakanlah eksperimental data kamu plot CA melawan masa, kamu dapat positive gradient, it means that your reaction is not zero order. Dia mesti negative gradient, negative slope. So you may ask, doktor, kenapa negative slope? Do you realize in the equation, depan tu adalah minus K. Minus K tu sama dengan gradient. Meaning, your gradient must be a negative value. Sebab tu, saya kata plot dia mesti negative gradient. So, kamu kena faham, if your reaction is not zero order, kalau kamu plot, dia takkan memenuhi keperluan ni. Dia memang very specific, only zero order. Experimental data saya, bila saya plot graph ni, hanya zero order reaction akan memberikan saya negative gradient. And second requirement, dia kena fulfill both. Dia mesti ada y-intercept, dia akan ada pintasan y. Kenapa? Sebab dalam equation kita kan ada y-intercept. Okay, so if your reaction, okay, you do the experiment, you got your experimental data, CA versus time, you plot the graph. If your plot fulfill these two requirements, then you can confirm your reaction is zero order reaction. If they don't fulfill any one of it, ataupun dia tak fulfill mana-mana satu, then the reaction is not zero order. You have to try equation untuk reaction order yang berlainan. Okay. Let's say kamu dah verify, dah betul zero order. Then you go to the next one untuk mencari nilai K. Okay, so you can see from the equation, your gradient is equal to negative K. Dan sebab nilai gradient tu negatif kan, sebab tu kamu akan dapat K yang positif. Sebab negatif K sama dengan gradient. Gradient tu nilai negatif, baru negatif tu terbatal, baru kamu dapat K yang positif. Sebab nilai K kena nilai positif. Right, so that's how you get your value K, and you verify the reaction order is zero order. So let's say you run, kamu tak dapat, your plot doesn't fulfill these two requirements. So we will go to the next one. Let's say sekarang kita cuba pula assume kalau reaction kita adalah first order with respect to A. So rate law dia menjadi minus RA equals to KCA, katakan. Okay, so again, kita integrate equation ni. Dan kita akan dapat the final equation kalau kamu boleh tengok dah dalam bentuk yang lain. So kalau your reaction is first order reaction with respect to A, your equation become ln CA0 per CA equals to KT. So you can see dah lain kan, tadi zero order plot equation lain, kita plot lain. Sekarang first order kita dah dapat equation lain. Plot kita pun mestilah dah berlainan. So again, kita akan tahu mana satu Y, mana satu data paksi Y, mana satu data paksi X. So you can see our Y-axis data. Okay, before I forget, this question is provided, tapi you have to really know by yourself. From equation tu, mana satu jadi Y-axis, mana satu jadi X-axis. So you can see naturally, Y-axis data yang saya kena plot mestilah data ln CA0 per CA. Dan data paksi X saya adalah time. Okay, so kamu kena ingat, data eksperimen kita adalah apa? Hanya CA dan time, right? So, maknanya kamu kena buat, katakan kamu kena plot graph, kamu kena wujudkan satu row yang baru di mana kamu akan mengira nilai ln CA0 per CA. Okay, so mungkin kamu tanya, tadi saya kata CA, kenapa tiba-tiba ada CA0? Macam mana kita nak tahu CA0? CA0 mestilah kepekatan yang paling pertama iaitu or the concentration when the time is zero. Sebab tu kamu dapat katakan, the first data paksi you will do ln CA0 per CA0. Data yang kedua, let's say minit yang kelima, ln CA0 per CA1. Kamu kira untuk seterusnya, then you will use this to plot the graph. Okay, so naturally again, if you see from the equation, K is your gradient. Okay, tetapi ingat saya kata, kamu kena verify dulu. Is it correct? Your reaction is first order. So you want to verify, you plot the graph of ln CA0 per CA versus time. Kamu kena ingat, dia masih eksperimen yang sama. Cuma data tu kamu kena plot benda yang berlainan mengikut equation dia. So pada equation tadi hanya plot CA lawan masa. Equation first order kena plot pula ln CA0 per CA lawan masa. Tapi nombor CA0, nombor time tu adalah nombor yang sama, kan? Right. So if and only if your reaction is first order, your plot will fulfill two requirement. The first requirement, dia mesti positif punya slope. So again, why? Tengok equation pun dah tahu kan, depan K tu tak ada nilai negatif, right? That's why your slope must be a positive slope. Let's say kamu If your tindak balas is not first order, you plot, you will not or you may not get a positive gradient. Okay, dan walaupun katakan dia dapat positive gradient, tak confirm lagi. You have to check the second requirement, which is dia takkan ada y-intercept. So let's say you plot, tiba-tiba ada y-intercept, then meaning your reaction is not first order. So kamu kena faham, kamu tak boleh paksa reaction tu ikut order yang kamu nak. Kamu kena cari order yang mana akan fit kepada reaction yang kamu ada. Okay, so again, if the plot fulfills the two requirement, provided you plot the correct data, you plot the correct thing, then you can confirm this reaction is first order and your value, your gradient is your value of K. So terus ambil je lah, dah tak payah buat apa-apa, terus ambil nilai tu. That is your reaction rate constant. Okay, so next one. Second order. So you see, even dalam kelas saya pun saya hanya cover the zero order, first order, second order. Okay, imagine if kita cover semua the reaction order, there will be a lot of equation. But you must understand, if let's say your reactions are something that you really don't know, as I told you, kamu pergilah differential method, kamu try lah half-life method. They are much easier sebab kamu tak payah assume. Satu kali eksperimen, kira data, plot graph, dah tahu nilai reaction order. Okay, now for second order reaction, I have to plot when I put it as minus RA equals to KCA power of 2, second order with respect to A, the final equation will be 1 per CA equals to KT plus 1 per CA naught. So you see now, equation dah berlainan. Kenapa? Sebab rate law kita dah jadi second order with respect to A. So the three equations akan diberi kepada kamu. So you don't have to memorize, but you have to know how to use it. So from the equation, naturally, 1 per CA will become your y-axis. Okay, maknanya data eksperimen kita CA kan. So, kamu kena reciprocalkan nilai tu baru jadi data paksi Y kamu. Dan paksi X kamu masih T. So, nilai T tu masa tu yang kamu dapat dari eksperimen, you don't have to do anything. You terus use it as a data for your X-axis. So, naturally, K will be your gradient again. And your y-intercept is 1 per CA naught. So, again, kalau only and only if your reaction is second order and you plot 1 per CA versus time, if your reaction is second order, they will fulfill these two requirements, which is first, positive gradient. Again, you can see from the equation, K tu positif, sebab tu kamu akan dapat gradient yang positif. And next one, dia akan ada y-intercept, which is again, naturally, kamu tengok pada equation, memang ada part yang y-intercept, sebab tu plot kamu akan ada y-intercept. So, if your reaction is second order, you plot the correct graph, your plot fulfill these two requirements, then you can further confirm, you can finally confirm your reaction is second order with respect to A, and you can see that the value of K is equals to your gradient. So that part senang. Okay, so you can see integral method I can say is easier sebab graf dia pun tak kompleks sangat nak plot. Dia cabaran dia adalah bila kita tak tahu reaction order dia, kamu kena trial and error. So you may ask, katakan kalau dalam exam atau dalam test, what will I do? Okay, so normally I will just ask you to verify. I will give you the plot, then I will just ask you to verify reaction order ni reaction order apa. So kamu ada equation kan? Okay, so kamu tengoklah apa yang saya plot, compare dengan equation yang kamu ada, and you have to remember kan, sebenarnya requirement plot tu kamu refer kepada equation dia sahaja. Kalau equation dia ada negatif di hadapan K, maka plot dia mesti ada negative gradient. Kalau equation dia belakangnya ada y-intercept, dalam equation tu ada part C dalam equation, maka graf kamu pun akan ada y-intercept. So kalau kamu perasan dalam first order, Y kita tak ada y-intercept. You can realize in the equation, part belakang dia tak ada C pun. Sebab tu plot dia takkan ada y-intercept. Okay, so that's how you can know the characteristics of the plot based on the equation itself. Okay, so let's say we try one question. Alright, okay, sekejap. Because since I already finished this method, this is also the last method. Okay, I will cover straight away tutorial question number 3. Okay, so tak apa, budak yang for those just now T2. Okay, I already covered question 1 and 2. So this is the third question. T1 on Thursday, I will cover the question number 1 and number 2, which is for the integral, which is for the differential method dengan half-life method. Tapi hari ni saya cover dulu untuk soalan nombor 3. So macam T2, this is your last question lah. Macam T1, this one considered as your first question lah. Tapi masih benda yang sama. Okay, so let's say we have this question on integral method. The liquid phase decomposition of A to produce B and C conducted in a batch reactor at 343.15 Kelvin. The following plot of 1 per CA versus time was obtained from the data. From the plot, the gradient was determined as 4.47 with a y-intercept of 179.95. Okay, so first of all, dia dah bagi plot dia and dia beritahu plot dia adalah 1 per CA melawan time. Okay, so tu benda pertama. So kamu kena faham kalau integral method, kamu nak kena carilah. Okay, integral method equation mana? Kalau dia adalah 1 per CA melawan time. So kamu kena tengok hanya one specific equation of which it will be 1 per CA and time. Kan tadi macam kita yang cover. Then dia beri kita the value of the plot. So they give us the gradient. It's a positive gradient. And the intercept, ada nilai intercept dia. Okay, so the first question, determine reaction order, the specific reaction rate constant, maknanya nilai K. Okay, then we will go to the next question. So for T2, maybe I dah mention, T1 I haven't mentioned. You must understand question chapter 5, dia bukan setakat soalan cari reaction order, cari nilai K, habis soalan chapter 5. So you must understand chapter 5 questions will be asked continuously. Dia akan combine dengan soalan daripada chapter berlainan, mainly chapter 4. Sebab ingat kan kalau kita nak buat soalan chapter 4, we need to know rate law, we need the value of K. So bila you learn chapter 4, most of the time rate law tu saya bagi, nilai K tu saya bagi. Tapi once kamu dah baca chapter 5, you will use apa yang kamu dah dapat daripada chapter 5, which is alpha dengan K. Kamu akan tahu rate law, then kamu akan dapat menjawab soalan seterusnya. Bila saya tanya kamu volume lah, so on and so forth. So you cannot study chapter 5 in silo ataupun just belajar chapter 5, tak faham chapter lain pun tak boleh sebab soalan dia akan berkait. So dalam contoh ni pun sama. Question A and B is correlated, but I will do question A, then later when you go to B, I will explain the correlation. Okay, so first question A, they want you to determine alpha and the value of K. Okay, so again, if you remember, we just learned kalau plot yang melibatkan 1 per CA versus time, the only equation that is correlated will be equation for the second order reaction. Di mana equation tu says that for second order reaction is represented by 1 per CA equals to KT plus 1 per CA naught. Okay. So first step, you verify first. Sama ada your plot fulfill tak requirement itu. So the first requirement, kalau kamu tengok equation, nilai K tu positif. Maksudnya plot kamu mesti plot yang positive gradient. So you can see dia memang positive gradient. Katakan daripada plot kamu confused ni positive gradient ke negative gradient. Tengoklah nilai dia. Nilai dah diberikan. Nilai is given as 4.47. So it's a positive. It's positive gradient. Okay, so dah fulfill requirement pertama. Requirement kedua, they will have a y-intercept because the equation ada part belakang tu yang mewakili C, y-intercept. So check your plot. Plot kita ada y-intercept and dah ada pun diberi nilai y-intercept. So correct. So the plot fulfills the two requirement of which I have a positive gradient and I have a y-intercept. So if both requirement is fulfilled, so you can conclusively say your reaction is second order with respect to A, meaning your alpha is 2. So when your alpha is 2, you can then write down already the rate law minus RA equals to KCA power of 2. So again, why 2? Because we confirm that our reaction is second order based on the plot. Then cari nilai K. So now that you dah boleh confirm dia betul, kamu tengok balik equation, you can see that K is equal to the gradient of the graph. So gradient was given as 447 from the question. Hence, your K value, your reaction rate constant value will be 4.47. Okay, so next part. the unit. Okay, so again, I have to explain to you how to find the unit. So remember, kalau second order reaction, the unit of K will be 1, the dimension is 1 per concentration time. Okay, so concentration mole per dm cube, right? Tapi dia 1 per concentration sebab tu dia terbalik, reciprocal dm cube per mole time, so minute. That's why you get the unit as dm cube per mole minute for your value of K. Right, so that's all. That's what you actually study in chapter 5. Tapi remember I told you, soalan dia takkan berhenti setakat tu. Sebab sekarang apa yang kamu dapat daripada part A, you will use in part B. So part B ni boleh soalan daripada chapter-chapter yang sebelum ni. Chapter 2, chapter 3, chapter 4. So that's why it's important you understand how it's being used. Right, so let us go to the part B. A new run is conducted at 323.15 Kelvin. Okay, so sebelumnya our reaction was at 343.14. Now I changed my new reaction at my reaction is now at a new temperature 323.15. So again, I always keep emphasizing to you, kalau suhu berubah, apa yang akan berubah dalam pengiraan kamu adalah nilai K. You have to find the new value of K sebab K yang kamu dah dapat sebelum ni, K tu dah tak valid sebab, tak valid, K tu dah tak boleh guna dalam pengiraan kamu sebab K tu pada suhu yang sebelumnya, which is 343.15. Okay, next. Dia kata lagi, given the rate of disappearance of product C as negative 0.70 with its outlet concentration of 4 and an 80% conversion of A. Calculate the activation energy in calorie per mole. So kamu nampak information dia a bit confusing. So sometimes reaction challenge dia bagi information but information tu berjenis-jenis information, of which is sometimes a challenge to understand macam mana information ni digunakan. Okay, so first of all, diberi kamu dah tahu the first information T2 323.15, my new temperature. If you remember, rate of disappearance tu adalah minus R, kan? Sebab kalau rate of formation positive R, rate of disappearance is negative R, and they say this is C for product C. So they give you negative RC. So diberi kamu negative RC sebagai negative 0.70. So again, negative di hadapan R menandakan it is rate of disappearance. Okay. Negatif di hadapan nombor 0.70 disebabkan we want to find the rate of disappearance of product C, tetapi product C's product C will be formed. So dia tak bersetuju dengan one another. Saya nak cari kadar kehilangan tapi C terbentuk. Dia tak bersetuju sebab tu nombor dia ada negatif di hadapan dia, negatif 0.70. So this is something that kamu belajar awal-awal chapter 1 sebenarnya. Okay, right. Dia kata lagi, its outlet concentration of 4 mole per dm cube. Apa yang dia beri kita? Dia beri kita kepekatan C selepas tindak balas. So this is something new, right? Sebelum ni kamu biasa C not, tapi tiba dia beri kamu CC, kepekatan C selepas tindak balas. Outlet concentration means after the reaction, my concentration of C is 4. Dia beri kita conversion 0.8. Again, kalau kamu confused dengan konsep conversion always refers to your reactant A. Walaupun kadang saya tak tulis conversion of A, kerana saya tulis conversion sahaja, kamu kena faham dia merujuk kepada reactant A. Okay? Calculate. Disuruh kita cari calculate activation energy. Disuruh kita cari EA. Okay, so katakan kamu confused. Macam mana kita nak buat ni? Sometimes it's good you do reverse engineering. You first figure out apa yang dia nak cari. Okay, dia nak cari EA. So kalau nak cari EA, kamu tahu mesti Arrhenius equation. EA takkan muncul daripada equation yang lain selain daripada Arrhenius. Dan kamu tahu Arrhenius ada dua version. Satu version yang menggunakan frequency factor punya information. Satu lagi yang K1, K2, T1, T2, which I hope you remember. So if you realize in this question, nilai frequency factor tak ada dalam soalan kita. Maksudnya tak bolehlah menggunakan the first version of your Arrhenius equation sebab tak ada nilai A. Macam nak cari EA, nak cari A pun tak ada, memang tak dapat solve. So we will most likely use the second version, which is K1, K2, T1, T2. Okay, sebab dalam kes tu, kamu perasan K1, K2, ada EA, ada T1, T2. Maksudnya, kalau saya nak cari EA menggunakan this rate equation, this Arrhenius rate equation, hanya EA yang akan tinggal sebagai unknown. Yang nombor lain, yang parameter lain tu semua kena ada nilai terlebih dahulu. You don't have value, I cannot use that equation. But I know itulah equation saya kena guna untuk mencari EA. So, kamu kena figure out, saya dah ada tak nilai K1, K2, T1, T2. So, let us see one by one. Okay, kita tengok belah kiri dahulu. K1, kita ada tak K1? Okay, remember, kita kan ada nilai K pada suhu lama kita sebab dalam part A kita dah solve, right? Kita dah solve pada suhu yang asal, which is 343.15. Kita dah tahu nilai K daripada part A, which is this one, 4.47. Part A dah beritahu pada suhu lama 343.15, nilai K kita 4.47. Okay, so K1 saya tahu. EA saya nak cari, R gas constant, obviously kita dah tahu. Okay, so kita tengok. T1 saya tahu, suhu asal saya 343.15. T2 saya tahu, suhu baru saya 323.15. Okay, maksudnya belah kanan equation saya dah tahu semua kecuali EA yang saya nak cari. Tengok pula belah kiri. Belah kiri mestilah nilai K2, which is K at 323.15. Okay, so sekarang tu yang menjadi masalahnya. Kita tak tahu K pada suhu baru. Tak tahu K pada suhu baru, tak dapatlah EA. So, now you form the problem statement. Kita kena cari dulu K pada 323.15. Okay, so how to do this? Okay, so you come back and realize that dia beri kita dua information. Minus RC punya information dan juga nilai concentration CC. Okay, so let us now figure out daripada minus RC dengan CC ni, di mana akan wujud K yang kita boleh dapatkan nilai untuk K pada suhu baru. Okay, so let's say you have learned that akan ada berkaitan between minus RC and minus RE. Remember, rate law yang tadi kita cari itu minus RE. Like, kamu kena faham, when we talk about rate law, it mesti minus RE. Okay, when you have minus RC, you can use the correlation to find minus RE. Maksudnya dalam kes ni, sebelum ni kamu terbalik kan? Saya beri kamu kena cari minus RA baru kamu cari minus RC. Soalan ni interestingly dia bagi kamu minus RC. So means we can actually use it to find minus RA pula, terbalik. Okay, so let's say if you remember correlation dia minus RC and minus RA, minus RC akan sama dengan negatif, nombor dia kena negatif like I explained previously why. C per A multiply with minus RA. Perkaitan antara minus RC dengan minus RA ni kamu dah kena tahu sebab you remember that chapter 1, chapter 2 kita dah always talk about this. Kamu dah tahu correlation ni. So I know my minus RC is negative 0.70. Okay. Reaction dia adalah 1A menghasilkan 1B dan 2C. Kejap saya lupa equation dia. Hold on Okay, the reaction is 1A to produce 1B and 2C. Sebab tu C per A dia adalah 2. The C per A is 2. Okay, so minus 0.70, your minus RC equals to negative C per A, negative technically kena tulis negative 2/1 lah, tapi 2/1 pun 2, right? So I didn't write 2/1, I just write 2. Multiply with minus RA. So now I get my minus RA as 0.35. Okay, so maybe you will ask, tapi kita nak cari K, kalau dapat minus RA pun apa yang kita boleh buat? Remember, minus RA kan correlated with the rate law. Minus RA kita dah tahu sama daripada previous part A, minus RA equals to KCA, power of 2. So, maksudnya daripada minus RC saya dapat minus RA. Saya boleh guna sekarang minus RA untuk cari K yang baru. Okay, so minus RA dia equals to technically KCA power of 2 kan, power 2, tapi kamu tahu masalah sekarang, masalah yang kedua, biasanya information dalam soalan dia tak akan beri kita CA. We also don't have CA if you realize in this question. Okay, so but usually kita akan buat dalam bentuk CA0 dan X, right? I always tell you kalau dia dalam bentuk CA ke sebagainya, you will have to find in the form of CA0 and X. So if you remember back, okay, sebab tu soalan reaction ni susah sebab kamu kena apply across chapters to solve the question. So this one you jump to chapter 3 pula. If you remember, saya dah ajar juga to express the equation untuk mencari kepekatan A. If it's liquid phase, CA sama dengan CA0 in bracket 1 minus X. Saya dah ajar dalam chapter 3. Okay, so maksudnya my CA square now become CA0 square in bracket 1 minus X power of 2. Sebab CA ni kita tak tahu. Kita terbitkan dalam bentuk CA0 dan X through this correlation. So if you cannot remember this correlation, you have to go back chapter 3, you have to look back at the correlation. Sebab tu if I may suggest, kalau kamu tu nak faham reaction, kamu kena faham chapter by chapter tu berturut. So kalau kamu faham chapter 2, it's easy to go chapter 3. Faham chapter 3, it's easy to go chapter 4. Tapi dia tak boleh reverse. You have to go step by step, chapter by chapter, baru kamu boleh faham correlation dia. Sebab tu bila saya ajar chapter 6, kamu akan tengok balik benda yang dalam chapter 5, kamu akan tengok balik benda chapter 4. So that's the challenge. Okay, so come back to here. So now, kita nak dapat K, right? Okay, so dia punya cabaran now, I know minus RA from my minus RC. I want to find K. The next challenge is I do not know CA0 juga sebenarnya. Okay, so itu yang masalah. CA tak tahu. Ganti dalam bentuk CA0 dalam bentuk X. X tahu. Cabaran dia pula tak ada CA0. However, kamu perasan dia beri kamu nilai CC. Outlet concentration of C is 4. So dia beritahu kita CC sama dengan 4. So again, kalau kamu balik kepada chapter 3, there's a correlation between CC and CA0 through the equation of which CC equals to C per A, CA0 X. So kamu kena faham pula, bukan saja correlation CA dan CA0 dan X, correlation juga between CC, CA0 dan X. So if you cannot remember this, it's in chapter 3, lepas stoichiometric table, saya ajar kamu untuk derive equation dia. Sebab tu kamu akan tengok kenapa saya ajar dalam chapter 3, dia muncul dalam chapter 4, chapter 5, benda yang sama. Okay, so from this equation, I have CC, I have X, I know my C per A, I will get my CA0. So baru saya boleh ganti CA0 dalam minus RA saya, baru saya dapat nilai K pada suhu yang baru. Baru saya ganti dalam Arrhenius equation, then only I will get my activation energy. Okay, so again, to even explain this to you is also difficult, I have to admit, sebab you will have to understand and figure out steps dia tu akan, I use this equation, tak cukup information, you need to use another equation, so on and so forth. So you will have to jump forward, jump backward, tengok apa information dia beri, macam mana nak correlate dengan apa yang kita nak cari, then only you can solve the question. Okay, so this is solution for the question number 3. I have this in my notes. Dalam VLE, saya dah upload notes yang ni. So if you want to really understand it back again, you can refer to that lah for the notes for this question. Okay, right. So I have few more minutes. I will finish the last chapter. So the final method is initial rate method. So initial rate method ni sebenarnya kita takkan pergi dengan lebih lanjut sebab method ni pun sangat tedious because you will have to run different experiment dengan menggunakan different CA0. Dia macam half-life method. And then lepas tu you have to find the initial rate of reaction which is minus RA0 dengan differentiate data dan extrapolate kepada zero time. That's why dia susah. Maksudnya kamu dah ada buat eksperimen, different CA0, kamu ada data dia. So data tu kamu akan cari minus RA dia. Okay, kamu kira minus RA pada X yang berlainan. Kamu plot data dia, kamu kena differentiate dan kamu kena extrapolate. Tu yang part yang menyusahkan. That's why I didn't go further. And memang kalau in the real application, this method is not preferred that much. The accuracy masih sama sebenarnya. Kamu guna method berlainan pun, at the end of the day, alpha dengan K tu adalah sama. Tapi as I told you, dia ada pro and cons dia lah. So again, same concept, you will plot the graph. Tapi graph dia adalah plot based on the equation. Ln minus RA0 will be your y-axis data. Your x-axis data is ln CA0. Okay, maka your M is your alpha. Your gradient is equal to your alpha reaction order. Your ln K will be your y-intercept. Right? Okay, so that's all. Just to explain to you the equation so that you understand there's a fourth method we call initial rate method. Okay, so consider today I already finished chapter 5. So I will probably finish this Thursday. I will finish tutorial chapter 5 for T2. I will go to lecture chapter 6. I probably can finish lecture chapter 6 Thursday ni sebab chapter 6 masih chapter mengira. Dia short chapter je lah. Equation dia panjang tapi dia punya chapter is not difficult one. I foresee I will be able to finish lecture next week. Chapter 7, 8. Chapter 7, 8 tu chapter membaca. Saya cakap sejam dah settle chapter 7, 8 by next week. And tutorial, I will also finish chapter 6 tutorial by next week. 7, 8 tu tak ada tutorial sebab 7, 8 tu membaca. So I foresee I will be able to finish tutorial and lecture by next week so that you have next week minggu 11 kan. So kamu ada 12, 13, 14 to focus on your test. I will still do physical test. So I will wait for you to come back physically. Tengok dulu macam mana. I heard most likely you can come back by after the 2 weeks off. But saya tak tahu. I'm not sure. It's not yet confirmed. But heard that most likely you can come back physically already. So I will still opt for physical test. Tapi saya tunggu dulu. Bila kamu betul balik baru saya announce bila dia. For you to focus on test and also on your lab. So kita ada 2 lagi lab. I think under Madam Nadia pun kita ada 2 lagi lab. So that's the part yang kamu burden lah. Bila kamu balik, kamu ada lab, kamu ada test. Sebab tu mini project tu next week hanya tutorial lecture, tak ada lab kan. Kamu tolong habiskan mini project tu and submit by week 12. So that when you come back, you only focus on your lab and your final exam. Right? So that's all from me for today. I will see T2 and T2 for tutorial on Thursday and the rest for lecture as well on Thursday. Okay, so thank you everyone. See you guys Thursday.